Type-safe casting in C#. C# is a type-safe language. This means that you can safely assign a value of one type to a variable of another type. In this animation, you will see how to use type-safe checking and casting, how the is operator works with the object hierarchy of C#, and how casting affects what an object can or cannot do after it has been cast as a different but related type. Here is an example. This airport control tower serves both commercial pilots and stunt pilots. Both commercial pilots and stunt pilots have training and licenses and can fly planes. In C# terms, pilot is a base class, and has training, has license, and fly plane are methods of the pilot base class. Two classes derive from the pilot base class: commercial pilot and stunt pilot. The commercial pilot class can perform all methods of the base class pilot, in addition to the climb 10,000 method. The stunt pilot class can perform all methods of the base class pilot, in addition to the do loop method. So, can commercial pilot perform a loop? You can answer this question by thinking along these lines. Who or what can execute the do loop method? Only stunt pilot can use the do loop method. So, no, a commercial pilot cannot perform a loop. In C#, you can instantiate a commercial pilot and perform both commercial pilot methods and pilot methods. You cannot perform stunt pilot methods by using a commercial pilot, but you can perform all pilot methods by using a commercial pilot. Why? Because all commercial pilots have a pilot embedded in them, so the pilot methods and the commercial pilot methods are available. The stunt pilot methods are not available. If you create a pilot variable called experienced pilot, which methods can you use with this variable? Only has training, has license, and fly plane. Now create a pilot variable and instantiate a new stunt pilot named Mike. You are allowed to make the experienced pilot variable refer to stunt pilot, but because experienced pilot is a pilot variable, it can only execute pilot methods. So Mike can execute the pilot methods. A method called fly plane has been defined that expects a pilot as a parameter. Inside fly plane, an attempt is made to execute the do loop method. Even though show-off is referencing a stunt pilot, its type is pilot, and it can only perform pilot methods. This code will not compile. Before invoking do loop, you need to convert experienced pilot into a type that can execute the do loop method. You can do this by using a cast. This should be safe because the parameter being passed in was originally a stunt pilot. The variable stunt showoff is of type stunt pilot, so it can be used to execute do loop. This act of deception says to the compiler, I know that fly plane can normally only be used to execute pilot methods, but I know it is really referencing a stunt pilot, so this should be safe. Trust me. But is it safe? What if you use the same fly plane method later with a different variable? For example, you create a new commercial pilot, Barb, and assign experienced pilot to Barb. Barb can execute the has license method and can even fly the plane. But a variable type of commercial pilot is used to reference Barb. So when Barb tries to perform a do loop, the program halts with an invalid cast exception error. The problem is that you asked the compiler to trust you, and it did, but you let it down badly. You should perform type-safe checking at runtime. To perform type-safe checking, you can use the is operator. The is operator checks to see whether a variable really is of a certain type, and returns true if it is, and false if it is not. This time, you check to ensure that experienced pilot is actually a stunt pilot before casting it and calling do loop. If experienced pilot is not a stunt pilot, the is operator will return false, and the do loop code will be skipped. In this way, you can ensure that a commercial pilot will not be performing loops. In this animation, you have seen how type-safe checking and casting work in C#. You have seen how the is operator works with the object hierarchy of C#, and how casting affects what an object can or cannot do after it has been cast as a different but related type.